Welcome to this video tutorial. In this video, I will talk about playtesting, debugging, and testing virtual reality applications in Unity. Now, just imagine you have a scene like this, fairly complex with lots of different objects that you can interact with. And in the middle of development, you will take some time and actually try to playtest and go through all the interactions, see what's broken, see what needs to be fixed, and see what works. Now, in a session where you test, you will probably have your headset on and you will have hand controllers if you're using something like the Oculus Rift or the HTC Vive. Now, in a scenario like this, you might be testing for 5, 10, 15 minutes. And one question I have for you is, how do you remember and quantify exactly what you need to fix later on? So let's say you encountered 5 or 6 different things that went wrong and that you want to remember for later that need to be fixed. So one option is you have a really good memory, and afterwards you just exactly remember what happened, where the problems were, and what you can fix. Unfortunately, my memory is not as good, so I need to find some way to record what I did and then where the problems were. One thing I could do is I could record the whole interaction, 5, 10, 15 minutes, on something like OBS Studio, and then later on go through the video and try to identify the individual moments where there were issues that I later have to fix. Another option is to individually just record small clips that identify exactly the issues that I want to address. Unfortunately, I don't have my hands free. I cannot go to the laptop all the time or to my computer and then start a recording. So I need something that I can integrate with my hand controllers in VR. Now, there's nothing out of the box that really fits that description, so I had to look around and try to build my own tools for this purpose to make it really easier to test my VR applications. And today I want to talk about those tools, how I built them, and how I'm using them. And hopefully this will be helpful for you as well to speed up your iteration times for testing virtual reality applications. Let's have a look. So the first thing we're using is NewtonVR, and this is my go-to for physics interactions in virtual reality. It is available for free on the Unity Asset Store, and all of the scripts that I'm using basically integrate the input of NewtonVR, and you can still use either the Oculus Rift or SteamVR with NewtonVR, and just give it a try. I also have a video online that describes NewtonVR a little bit more. Now there's other tools out there, for example, VRTK or just the SteamVR integration, and all of those will work as well. You will just have to adapt the input controls that I'm using for my scripts. The next thing that I looked at is the recorder, because my requirements were to easily just record short clips in Unity and to save those to my hard drive. Now, the recorder from Unity really does that well. It's a neat little tool that was developed mostly for Unity 2017 and 2018 now. Unfortunately, there's a limitation that Unity Recorder is only meant to record in editor. However, I wanted to build my applications and then test them on a different computer, so that it wasn't feasible for me to use Unity Recorder. Now, if your requirements are to simply test your application while developing in the editor, then you should probably look at the recorder because it's fairly easy to use and it's only getting better right now. It's receiving quite a bit of attention from the developers at Unity, and it records either in 360 degrees or also just normal videos and works quite well. It can also be integrated with timeline, so have a look at it. Maybe it works for you. It did not work for me. That's why I kept looking, and I already used RockVR's VR Capture in the past. Unfortunately, I purchased the VR Capture Pro, which doesn't exist anymore, but luckily for you, there's still a free version, which is called VR Capture by RockVR. And that's also what I'm using in this tutorial here. So you will see RockVR again in the scripts when I talk about them in a little bit. Another thing that I did was I integrated microphone input because my requirement was I wanted to have short little clips where I also briefly talk about the issue that I just encountered so that later on I will have a brief description of what just happened and I can just record that using my microphone. Now there is some code here that's on the Unity support side, and I simply use this in one of my scripts. And lastly, I also wanted to build small little tools to tell me, for example, the frames per second of my application, to look around and to identify issues where maybe there's some objects that are not optimized enough. And so I used the frames per second script from the Unity wiki. It's fairly old already, so I adapted it for the new GUI system. All right. Now, I also built a teleportation system for NewtonVR and integrated all these things together. But let's see all of this in action. I recorded the video here, which is basically the final result of what I wanted to achieve. And this is the same scene that we just saw, the kitchen. And we have the HTC Vive controllers. And you can see already this laser here, this pointer is for teleportation. But also if I pointed at something, I can see here what the name of the object is to later identify exactly what kind of object I dealt with. So it's a neat little tool that I can use for teleportation, but also just to point at things and to find out what object it is. The other thing we have here is a frames per second counter. Now you cannot really see it that well because the resolution of the video is not super high, but it will tell me exactly what the performance of the application is right now, at least in terms of frames per second. And altogether this clip here was recorded directly in the Unity build. Now I didn't say anything during this recording there, but it definitely supports microphone input. And I can start and stop the recording and also just pause in between and sort of have short little clips of different moments where I need to record my application. All right, so this is it in theory. Now I will go through the different scripts and tell you a little bit about how I developed them and how they can be used. Let's get started. Okay, so here we have our environment. In this case, it is a house called Suburban House. It's an asset available in a Unity asset store. Now, I cannot share the whole scene or any of those assets since they are available in the asset store and are not my own. But I will make available the scripts that I created, and you can find the links below this video. And feel free to modify them. If you have any questions or feedback, just leave comments below. All right, so how do we get started? So firstly, I imported NewtonVR. Scroll down here, take the NewtonVR player, and just plop it right in the middle here. Now, I already have SteamVR enabled, but you would have to probably push the install SteamVR SDK button. And then once it's installed, just enable SteamVR. That will guide you sort of through the installation process. Now, this player is also a little bit small, as you can see, almost like a child compared to the environment. So I'm just going to increase the scale to 1.2. Other than that, we can leave this object as it is right now. And the first thing we'll do is I have this little FPS display already created, but you can easily recreate that. It is nothing but a small canvas. It's a world canvas at a small scale. It's part of an empty object here. I will make this info display script available, and you might not need all of this text, or you might have different things here and instead of FPS and target text. So you can just modify it as you see fit. But we have two Text Mesh Pro text elements for frames per second, the top half here, and the bottom here is for target objects, so what we're pointing our pointer at. And then we have these two little images, which are just little cubes to indicate whether we're just recording or whether we're pausing our recording rate. That's all there is. It's really just a small canvas. And I will attach this to the left hand. I'll make sure that it's right at 0, 0, 0. And we link our hand here to the info display script. And that's all there is right now for this little canvas. All right. Next, we'll have a look at the right hand. And here, we'll simply add our teleport script, and I call it SteamVR Custom Teleporter because it's vaguely based on the SteamVR teleporter script. There's really not much left of it. I'll go through the script in a moment, and we'll just set our two colors for non-targets and then for targets. Line width we can leave as is, or make it a little smaller. And here we have a slot for an array for colliders. And this is really because out of the box, this script previously didn't have any selection of colliders. You would simply teleport to any of the colliders. And that's, I feel really bad for users, because here in this environment, everything has a collider, or almost everything has a collider. So theoretically, you could use this this pointer and just teleport on the chair here. Could teleport right through the wall, out here in the yard, and so on. So especially for somebody who's not used to VR, that might actually be really really dangerous, and might really get people upset, possibly sick, because they're not used to, first of all, teleporting around in the first place, and then all of a sudden being, fairly high up, or even falling off the. If you go out here, you can easily fall off the ground plane and then just fall down, and it would be absolutely terrible, because yeah, people are not used to that, and might get sick if there's a lot of movement, a lot of unexpected teleportation going on. So instead, I would then just click on the floor here, find the floor object, maybe also the second floor, and then maybe the carpet out here, and we would go to this array, just drag our colliders in here. Now, if these floors don't have any colliders attached, we would have to attach colliders, and that should be enough. And the last thing is we need to link up our display, and that is because we want to set the object, the target object that we're pointing at right now, to this display here, and that's determined by the raycast of our teleporter. All right, let's have a look into the script. So now you've seen sort of what we set up here. Teleporter, first of all, has our public variables up here for the colors and so on. We need some variables for the raycast and our display, info display. And we set everything up, all the default values. And then in the update, we enable our line renderer. So the two things we need here is a line renderer and the NVR hand. And we enable the line renderer whenever we hold down the touchpad. So this could be over multiple frames, so you can keep the touchpad pressed and the pointer will be enabled. Now, whenever it is enabled, the line renderer, we set its target to the non-target color first. We do our raycast. And now our raycast, if we hit something, we then set the positions of the line to 2 points. The first one is right at our controller. This is where we're at right now. Then whatever we hit, which is this hit info object, the raycast hit. And this is the point of the collider that we hit. And that's our laser pointer, basically. Now, next we check all the colliders that we specified here in these teleport collider array. And if one of them matches, we set the color to whatever we set as the target color of our line. Now, if we don't specify any of the teleport colliders, then we can teleport onto anything. So everything is a target, basically. Whatever has a collider attached is a target, and we can teleport anywhere. And lastly, we update our display with the name of the game object that we just hit. And if in a certain frame we also let go of our touchpad, then only if we at that frame also have a target in our line of sight with the laser pointer, then we teleport there. And teleportation is nothing else but moving the whole NVR player object. We're changing that transform position based on the information we have from our raycast. We take this NVR player and we move from one position to another. And that's all there is. So that's actually pretty straightforward. That is the teleporter. Now you could extend this a lot, and the SteamVR version of this is much prettier with the arc and the animations of the lines and all of that. But this is really just sort of for debugging purposes and for just moving around. Even if you don't need any teleportation or have other means of moving around in your actual game, while you're testing your environment, you might need to get around quickly and just need to teleport to certain spots to interact with objects and test stuff. And for that, it's I think pretty handy, just because NewtonVR out of the box doesn't have a good teleporter at all. All right. What's next? Next, we want to record our video and audio. So what do we need for that? So I have RockVR, the VR capture imported. Now up here we have a menu item, and we need a couple of things. First thing is a video capture control, and we don't have to attach that to anything. What we'll do is we'll set it to debug, quit after capture, and we remove everything else from this object, just because we don't need all these things. We don't need a video player and a UI for video playing. Next, we go to our head. Now, the head is where our camera sits. This is what Unity uses to then also render the two different cameras for each eye, and that's this camera here. Remove the GUI layer. I don't know why any camera still has that on. And one thing we need to add here is an audio capture. That's a RockVR component as well. That is because the audio listener is here and the camera is here, so the audio capture needs to be with the audio listener. All right, next we need to record video. Now, video recording with RockVR has two different options. First one is a direct capture of our main camera, and this works with NewtonVR quite well. So I would simply add a video capture, main capture, or 360 capture as well if we want to record all of VR, the full 360 degrees. But in our case, we will only capture just a forward field of view. Now, the main capture would record this camera right here. Unfortunately, that really doesn't work that well, just because this is a camera that will be used by Unity for VR, so it would be split into two cameras with two different viewpoints and so on. And video capture doesn't really like that, so we have to remove this again. That's not an option for us. Instead, we use a so-called dedicated capture. That was not very nice of RockVR because it renamed our head into dedicated capture. Now, instead, what we'll do is we will add a dedicated capture to our head. And dedicated capture is a separate camera that will be recorded. And it's basically a camera with a video capture attached and this dedicated camera checked. Now, this is not the camera that we'll be rendering through for our main view while we are in VR, but it is simply the camera that will be recorded. And we make this a child of the head because we want this camera to be in the same spot as the head camera that our head-mounted display uses. So we can record the camera that has the same point of view as our user will have. This will be a little bit tricky, and I'll explain in a moment why. Set this all to 0, so it's in the exact same space as our main camera. And we have a couple of options here. First of all, we can use a custom path that will be in our project folder and create a folder called recordings or whatever you like to call it. And then we have the frame size, so all of the different quality settings we have here. And that's all there is. We can click Open Save Folder to show the folder to find those videos later on. Other than that, that's all there is. I usually just leave it at 1280 by 720, but you might want to record 1080p or higher, depending on how good your computer is and how much you actually need to see later on. For me, it's enough to really just get the general gist of what I was doing there and sort of what issues occurred and what kind of bugs I was encountering and so on. All right, what else do we need? So we go back to our video capture control. It already found our dedicated capture here once we added this, and drag and drop our head in here with the audio capture. All right, next we add a little script called recorder control. I wrote the script and we require just a few different things here, a few different references. The first one is the hand. This will be the hand that will control our recording. In this case, I want to record with the left hand, so pressing a combination of buttons on the left hand. And we have these recording images and pause images, so these are the indications of whether we're recording or not. Out of our canvas. And lastly, there is the microphone input. I'll explain that in a moment as well. A little script that we just add here and drag and drop in. All right, let's have a look at this. Open up our recorder control. And here we have those references. And in the update, all there is really just checking for the combination of buttons to start and stop our capture. So when we start, we turn our microphone recording on, and we start our capture with the video capture of RockVR, and we turn our little icon on to show, hey, we're recording. All right, and we turn the same thing off when we stop recording. And the same also goes for pausing and resuming, but in this case, it's called toggle capture for RockVR. All right, now this last piece here is a little interesting. I'll explain what we're doing here. We're basically keeping the local position and local rotation at 0, 0, 0, or at quaternion identity. And that is basically related to this object here, so the dedicated capture. And as I mentioned before, we want this to be in the exact same spot and the exact same rotation as our head, so that we get the same view as our main camera. And this means that all of this up here needs to stay at 0, all those numbers, position and rotation. The problem with NewtonVR is that for some reason, it takes in the tracking from, in this case, SteamVR, and this tracking usually is only applied to the head. So our head is our camera, and wherever our headset is, this will the head object will follow around and will be tracked. Unfortunately, the same tracking data then also applies to any of its children, and which is really odd. Which means that our head might be 180 centimeters above ground, and then our dedicated capture will again be 180 centimeters on top of that, which doesn't make a lot of sense. Instead, we want again all these values to remain 0. So what we're doing is each frame we have to set these things to 0 again, which is unfortunate, but it seems to be probably just a small bug somewhere in NewtonVR. But I don't want to mess with that code right now, so instead I'm just overwriting those values here so that they stay at 0, 0, 0, and follow our head around so that we can record exactly what we need. All right, and that's all there is. And now with just those button presses here that we set up, we can actually control our recording. Now you can change those buttons to whatever you like. I also have some buttons here to test in the editor with space and the return key. And you can change that to your liking. All right, so this is RockVR setup. Let's talk a little bit about the microphone. Now, why do we need extra microphone input? Now, one thing that's really common with all those recording tools is that they only record in-game audio, so anything that's being played within Unity. So one of my requirements was that I wanted to sort of have a voiceover whenever I record something, so that I can show whatever interaction there is in VR, but also briefly explain while I'm recording, hey, what is this? So that later on when I watch those little video clips, I will remember, okay, basically I will explain myself later, hey, this is what happened here, and this is what I think is causing this, and then later I can check that. So I wanted to sort of have some voiceover over that, and obviously we need microphone input for that. And if you use something like OBS Studio, you can just record any audio input from your computer, but if we record within Unity, we're only limited to things that are playing within Unity. No other microphone audio is supported by RockVR or by Unity's recorder, and by pretty much all of the other tools as well. Now, there are separate tools that record your microphone, but you can simply use this little script here. I wrote microphone input here, and that is actually from Unity, from the support forums. And all we're doing here is we can set it to play on awake, but we actually want to trigger it manually whenever we start our recording. And the only thing we're doing is we take this audio source, and its clip is being set to our microphone. So the input from the microphone, we call microphone start. This first one here is the microphone we're targeting. If we set this to null, it is the default microphone of your system. So most of the time, this will be the correct microphone. Otherwise, you would have to actually list all the different devices and then search for the microphone you're looking for, but this should do the trick in most cases. We set the loop true, and this line here actually specifies what kind of delay we want. Now, we don't want any delay. We want to play back the audio that we're talking into the microphone instantly, so that RockVR, the recording, can pick it up and we can record it. Now, then we just use play, and at the end we just stop everything and stop the microphone input as well. And this will really cause the audio that we're like, whatever we say in the microphone to be played back immediately, which is a bit weird because you're hearing an echo, you're hearing your own voice while you're recording this. But first of all, it's not too disrupting, and it's only for short little clips whenever you just document sort of the error that you just found or the interaction that you want to document, and you get used to it really quickly. It's not a big deal. But that's basically the only way I could find, apart from using external tools like OBS Studio, to have a video recording in Unity and also have microphone input. If anybody has any other solutions, please let me know in the comments. I'd be interested to hear what you found for this. That basically means so far we can record video and audio and microphone, and we can also pause and resume so that in the end, after maybe a 10-15 minute play session, we have a collection of little clips that would just show and have voiceover to sort of what was going wrong and what we need to fix later on. We covered the teleporter, and that's really all there is to this little tool. Now you can extend this to have as much information in there as you like. You could change this FPS display to also display, let's say, the number of vertices of the object you're just targeting, or to show you the number of batches that are being used right now, what is being rendered on screen. So there's a number of things that might be relevant for your playtesting and for optimization and for testing different collisions and so on and interactions. So there's really a number of things. There's one thing that I usually do as well is when we make any objects interactive. So let's say I want this cup to be interactive. The first thing I need to do is I need to take the static flag off. I need to add a rigid body, and I need to add an interactable NVR interactable item. That's all there is to it, and you can already now pick this item up and throw it around and so on, so it has physics properties, and it works quite well. And what we have done here is those events here, Unity events, on begin interaction, on end interaction. One other thing I really like doing for playtesting or for sort of documenting what I did step by step, or data collection, because I'm using most of these applications for scientific research, is to actually write to a text file, local text file, or to a database somewhere, online backend, the name of the object and the timestamp of when I interacted with something, when I dropped it, and so on, and where the item was, etc. And you can do that here just through on begin interaction, on end interaction. But I'll keep that for a separate video for recording all of those things and sort of having a ledger of interactions of your user, so you can see sort of what went wrong where, and maybe what were the actions leading up to that event and so on. Okay, so that's all there is right now. I hope this was helpful. If you have any questions, any feedback, let me know in the comments. And thanks for watching. I'll see you next time.